All right, hello everybody, welcome back. Carl again. Today I want to talk about Electric Railroad Company products activating a Lionel whistle tender. So here is my whistle tender. This is the shell, it's a Lionel Scout. And inside of the tender is a specially designed plastic that has little holes on both sides, a DC motor, and then this circuit. Now, I have installed a cruise Lite module there. Now, originally when you get this board here, the original circuit is actually over here on this post, and I just moved it because I didn't have any room with the tender. And let me talk about how I actually got this to work. It took me about a week to figure it out. Now, on the Cruise Lite manual, it talks about horn control to contact them. And I did contact Electric Railroad, and they gave me like this generic response of, there's so many out there, we don't know how to make them work. That didn't really work for me because I want to make the original whistle tender work. Now, on the Cruise Commander manual, it talks about electronic whistle tender, and actually what you need to do is from pin 3, you connect a wire to this point here on this resistor. Now, this is the board that came with the whistle tender here. Now, my component values were different. Mine were 1K and 10K. Here is 4.7K and 1K. So here is actually what I ended up doing. On this board, I have attached a wire to this part right here on this resistor. So I actually attached it to here. Now, I believe, if I remember correctly, these two are connected together. Yellow wire is attached there. That runs over to this little circuit that I designed. And let me show you what that circuit is. So that circuit is for a Lionel trained whistle tender. And here I use a 2N222A, and that's in a little can. So this is the bottom view of the pinout. And I have the emitter going to ground. I have the base through a 1K resistor to the Cruise Lite, that pin 3. And that talks about it here. And it's the same story with the diesel horn. Here you have serial data, you have nothing, common, and hot. You have to attach that wire right here. So I pried the purple violet serial data wire out of that connector and put it in there. That then goes through a 1K resistor and connects to the base of this 2N222A. So when you hit the button on the TMCC remote, that pin 3 sends a high to this transistor. That then activates this transistor, basically connects the collector to ground. And then here I have a 2N3906, which is a PNP transistor, through a 1K resistor to the base. The emitter goes to VCC, and the collector goes to the factory whistle tender. And that is this point right here. So, on this side of the circuit, pin 1, which is the red AC hot, it needs to go through a diode. And I used a 1N9148 or 1N4148, just a general purpose diode. That is the VCC, and then the black goes through the common, through the same diode here, and then that's ground. And so that needs to tie to all these points. So when I say ground and VCC, that's these ground and this VCC. It's completely separate than the train because that's AC voltage. And what we're really doing here is making DC voltage. And then also on ground and VCC, these pins, we need a capacitor. And I just used a 100 UF 25 volts. Just want to show you what that board looks like. Here it is. This is my PNP transistor. This is my NPN or 2N222A. You can see the 1K resistor down here connected through that purple wire. You have the two diodes and then of course the capacitor. So when you hit the button, it sends a high on this purple wire here, which you can about make out. You see red, black, and then I moved the violet wire over. That goes to this board, which then goes to this board and then works this motor. So that was my solution for actually making the whistle tender work. I'll go ahead and post schematic, this circuit here down below, so that if you're interested in making your Cruise Commander product work with your factory whistle tender, that might be the solution. So in developing, I actually blew up this transistor. I blew up these 2 resistors. So hopefully you don't have that same problem. You can just make this circuit and actually implement it. All right, well, thanks for watching, guys. Until next time.